Welcome back to Code Meets World. Today we're looking at LeetCode problem 128, longest consecutive sequence. So we're given an unsorted array of integers, and we need to return the length of the longest consecutive sequence of elements. And this must run in O of n time. So what that means is, given an input array, we need to look and see the longest stretch of consecutive numbers. So in this example, 1, 2, 3, and 4 are all consecutive numbers, and they have length 4. So the solution here would be 4. And then with this example down here, it looks like you can make 0 all the way up to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And so that's length 9. And notice there's 2 zeros here, but that doesn't really matter. We just ignore the duplicate and just use 1. So this is the second example from the problem write-up. And the output here, the solution that we should get is 9, because you can make 0, 1, 2, 3, 4, 5, 6, 7, and 8. So for how to solve this, one thing that we could do is we could go and start looping over all of the values in the array. And so we would start here at this 0, and we would say, okay, let's see how big of a list we can build. So when we do that, just like I showed in the example, we would be able to go from 0 all the way up to 8, which equals length 9. After that, we can move to the next number, which is a 3, and we could start at that 3, and we could go as high as we could. So just like we did with the 0, we would start at 3, and then what comes after 3? 4, 5, 6, 7, 8. And you'll notice that that is length 6 if we go all the way up to 8. We could keep going and do the same thing, starting at 7 and increasing. So we would just go 7 and then 8. So that would only be length 2, like that. And we could just keep going. And once we make all of them, we could just go through our list and pick the biggest one, which in this case is going to be 0 to 8. This is not as fast as it could be, because we're wasting a lot of time by, in this case, we found the best one right off the start, but then the whole rest of the time we're going to be counting other sub-sequences that are part of this original sequence, and so are obviously going to be shorter. So there is something better that we can do. I will mention that one way we could solve this problem is by simply sorting this input array. So we could sort it and it would end up looking like 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we could just walk through and count how long our sequences are. So from here to here, that's the same number, so the sequence length is still 1. Now it goes to 2, and then it goes all the way up to length 9 here. And that's one way to do it, but if we did it by sorting, this would end up being O, because sort would take log n, but then after the sort, we would have to go through and count how long the sequence is. So this would end up being O of n log n, which is good, but it's not quite the O of n that we're looking for. So that solution is not going to work here. I just wanted to mention it. But there's a way we can do this so we can skip all of the subsequences. So once we've seen this big one, we don't have to look at any of these other ones. And the trick to doing that, I think, is when we're going through and iterating over and checking a number, if we have already, or if the array contains one digit smaller than the value that we're looking at, we don't need to process that chain because we know we're going to process it with the smaller chain. Let me show you what I mean by that. So again, we're going to start from the beginning like we did, but with this new idea. So we'll start with 0 and we'll make that chain. That's going to go through like we've showed and go from 0 all the way up to 8, which equals length 9. Then when we go to the next value, which is 3, last time we just started with the 3 and counted as high as we could go to 8. But what I'm thinking that we do this time is, because if we take 3 and subtract 1 from it, so in that case 2, we ask ourselves, is the number 2 in our list? And it is. It's right here. And the theory here is that because 2 is in here, let's not calculate the distance from 3, because we know that whatever the distance is from 3 is going to be shorter than whatever the distance is from 2. So there's no use calculating the 3, because the 2 is connected to it sequentially, and the one that starts at 2 is going to be longer. So there's no use calculating the one at 3. So when we get to 3, we just don't do it. And the reason we calculated 0 is because we would first check is -1 in the list. It was not in the list, so we'll start and calculate at 0. So we'll calculate 0. We're not going to calculate 3. When we see the 7 next, we ask, is 6 in the list? It is, so we don't calculate the 7. When we go to 2, we ask, is the 1 in the list? It is, so no need to do this. And same thing, no need to do 5, no need to do 8, or 4 or 6, because the value -1 is in the list. When we get to this 0 again, technically, we've already done it. So what I'm thinking in our final solution is we don't allow any duplicates. So we could convert the list into a set at the beginning to remove the duplicates, because we don't want to look at the 0. And then finally we get to the 1. So we ask ourselves, have we calculated, or have we seen 0 in the list? The answer is yes, so we don't need to calculate 1 either. So amazingly, with this method, we only have to run one sequence, which is on that original 0. All the rest of them we won't end up doing, and at the end of it, we'll just return the final answer is 9. Because there could be other ones where we have multiple sequences that we check, and we just need to keep track of this largest value at the end. The first thing that we're going to do is remove all the duplicates by turning the input array into a set, which will just remove all of the duplicated values, no matter how many times they're there. So I'll call this all, and I'll set it equal to the set. And then if you pass in a list into the set in Python, it will just make a set out of it and set that as all. So we'll do that, and then we'll set a variable for the longest chain that we've seen, set that equal to 0. And now we're ready to loop over all the values in the list. So we can say for num in all, so we're looping over the set here. And this is not going to give us the values in any order, because sets are unordered. So it'll just be a random ordering of all the numbers, not chronologically. And so the first thing we want to check is this value -1 in the set? Because like I mentioned on the whiteboard here, for any number that we see, if that number -1 is in the list, we don't need to check that number, because we know that there is a longer chain that we'll compute earlier on with the other number. So we can say if num -1 is in the set, which I called all, if that happens, we can just continue, which will just go to the next iteration of the loop and check the next value. Then, in the case where num -1 is not in the list, so for instance, in the case of 0 in this example, 0 minus 1 is -1. That is not in the list. So in that case, what we want to do is build this actual chain and see how large it is. So to do that, we can set a current length, and I'll set that equal to 1. And then I can say, because I just want to loop, while num plus current length is in all. So what's happening here is I'm taking whatever number I'm on. At the start here, I'm adding 1 to it. And I'm checking, is that value in the list or in the set? So on this example, I'd be taking the 0, I'd be adding 1 to it and saying, is number 1 in the set? And it is. So while that value is in the set, we can say current length plus equals 1 because we're growing the count of how many sequential numbers we've seen. So we're adding that, we're incrementing that by 1. And at the same time, this is also incrementing what we're checking each time. So first we check, is 1 in the set? It is. So we make our current count or our current length into 2. And then we can check, okay, is num plus current count? So num, which was 0 at the start, 0 plus 2 is 2. So now we're checking, is the 2 in the list? It is. So we would increment this to 3 and then add 0 plus 3, which is 3, and check is 3 in the set, which it is, so on and so forth. Once we eventually reach a value that is not in the set, so we've ended our chain, we need to see if this sequence we've found is larger than our longest, because we might see multiple sequences. So this time we can say longest is equal to the max of whatever longest currently is, and then the current length variable that we just computed. So this will just replace longest with either itself, if it's still longer, or the chain that we just found, if that one is longer. And then once we're done with all of this, we should just be able to return longest. So let's run this. See if there are any issues. That looks to be accepted. So I'm going to submit. And there we go. This solution passes. And if you can see on the little histogram here, this is as fast as you can do it. So even though this is only 59th percentile, all of the solutions are the same percentile here. So that's how you solve this one. And let me know in the comments if you have any questions. I'll see you in the next video.